Hello, everyone. Thanks for joining us. Today we're going to talk about how Pandora moved and migrated its on-premises BI and analytics to GCP. I'm joined by Brett, who's the VP of Platform Services at Pandora Media. And I myself am Blake Dubois. I'm part of the professional services organization at Google Cloud, helping some of our largest customers move and migrate their Hadoop to GCP. We are going to be using a Dory today. It's accessible through your Next app. We encourage everyone who has questions now or throughout the talk to just go into the app, jot them down. If you have time to look at the existing questions and possibly upvote them, at the end of the talk, we're going to be taking questions from the audience at the microphones and the Dory, alternating. Thank you. And lastly, just a little bit about the agenda. Brett's going to give an introduction to Pandora and talk about the big data evolution. We're going to talk about why Pandora chose to move to the cloud in GCP specifically, some of the evaluation and results that took place before their commitment, and we're going to go into some of the technical details around the solution re-architecture before kind of finalizing with the rest of the roadmap for the year and what we hope to see Pandora present at Next 2020. Brett?
Cool. Thanks, Blake. All right. So who we are, Pandora. Can we get a show of hands? How many of you have used the Pandora app before? All right, it's great showing. Thank you very much for listening. Another show of hands, how many of you have used our on-demand service, our premium? Okay, pretty good. Now, how many of you know that you can search and play with our free ad-supported version? Have you tried out that feature yet? Even smaller group. Okay, well, go check it out. It's a really exciting feature. We launched it a few months ago. We're really excited about it. But one of the things we do at Pandora that's really at sort of the core of Pandora is our personalization. So the idea with Pandora is that you can have a lean-back experience. You give us some cues, and we program a continuous stream of content for you, whether it's music or non-music content like podcasts or comedy. So, at the heart of this personalization is our analytics system. It's really the workhorse behind it. So we have a lot of data. 68 million users in the US. We've got those users have created over 13 billion stations over the life of Pandora, and 90 billion pieces of feedback, thumbs up or thumbs down, telling us what they like or don't like. And we use all that data for this personalization. So I'll tell you a little bit about the history of big data at Pandora. I've actually been at Pandora 11 years and was really involved since the beginning with analytics at Pandora. So we launched Pandora in 2005. In 2008, 2009, mobile really exploded, and the usage of Pandora really took off. So originally, we had a single Postgres database. We were stuffing all of our analytics data into it, and it didn't scale very well, as you can imagine. So 2010, we started experimenting with Hadoop on-prem, and we built out our first Hadoop cluster, moved all of our analytics over to Hadoop. Started with a very modest cluster, 10 servers, Apache 0.17 and Hive 0.5. And we've grown on-prem quite a bit. So every year we've had growth. We've added more engineers, more analysts, more scientists, all working on a single cluster. We have one production cluster that runs everything on Pandora. And we've also added a lot of personalization features. So thumbprint radio, if any of you use that, personalized soundtracks, autoplay, all these personalized features for our listeners. We've also added features for our advertisers as well. Really cool campaign reporting tools, some really advanced forecasting so they can make sure they have the right campaign, and some cool segmenting and targeting as well. So with all those features, with all that growth, we grew the cluster. So today, we are up to 2,700 data nodes, 7 petabytes of data. and quite a few resources on this thing. So 270 terabytes of RAM, 76,000 vCores. Just a 10,000-foot overview of how analytics works at Pandora. We have the data ingestion side of things. We leverage Kafka really heavily. Almost all of our kind of real-time event data that happens as you trigger actions in the app comes through Kafka now. We use Scoop and some homegrown tools to load data from our relational databases into Hadoop. Load all that stuff into HDFS, leverage Hive and Spark very heavily for all our ETL and batch workloads. Presto and Hive are the primary tools that our scientists, developers, analysts use as they're looking for insights. We also have a couple BI tools we rely on heavily, Zeppelin and Tableau for insights. And then, a large percentage of what our workload is on the cluster are really jobs that our development team, our science team has built, doing that personalization and pushing that personalization that we do typically in a batch process into production stores that we can run our real-time services off of and make these decisions in real time. So Postgres and Redis in particular, we rely on really heavily. So disaster recovery with our current on-prem architecture, we have our main colo, which is in San Jose. We do have a backup. I would call it more of a business continuity backup, not true disaster recovery. We have a much smaller cluster, very data dense, that's located outside of DC. We have a 40 gigabyte link that we copy data to pretty much all the time to keep that at least a copy of our data up to date. But the big drawback with this is if we did need to fail over and rely on our backup data center, it would take us some time to scale that out to really take on the production workload. It's just not feasible to run two clusters the same size and just be sitting idle all the time. So why cloud? We've been on-prem for a long time. Why would we kind of pick up and move to the cloud? And that was a big question for us. So, a lot of different reasons. Bursty workloads is a really interesting one. Let me just put a pin in that for a minute. There's a cool slide I want to show you next that gets into that a little bit. But another avenue of flexibility is hardware choices. So we have different workloads. Some of them, Spark, Presto, very memory intensive. They can do a lot with the memory if you give it to them. And all of our jobs are different. We have one single cluster, and we run a lot of different types of workloads. So being able to switch to a model where we've separated storage and compute, and we can spin up purpose-driven clusters with different profiles for different workloads is really appealing to us. Also, multi-regional. I mentioned the DR situation for us. Being able to have a true disaster recovery is pretty cool. Reduced maintenance. As the cluster's grown the last 2 or 3 years, we've spent more and more of our time operationally just keeping the cluster running for all of our users. We've got about 150 users on the cluster across the company, and managing the resources between them, we've hit quite a few bugs just because of our scale. Things like storage tiering and also understanding costs at a more granular level has been really cool. So this is another one on flexibility here. This is a chart of our Hadoop utilization over a month. And if you look at this chart, you say, okay, well, things are looking pretty good. You're under 40%, 35% across the board as a mean. But because we run one cluster, we have a lot of different users on it, we're actually resource constrained a lot of the time. People come in the morning, they want to execute their queries, they want to learn about what happened the previous day, and so we have bottleneck and backup. So even though this looks good, it's really not that efficient because when people want to use the cluster, they can't always get instant access to it. And so we looked around, we looked at the different cloud providers, and something that really meshed well with Pandora and what we're trying to achieve at Pandora, it was a good fit for GCP and the Google team. And I think the things that stood out for us is really the distributed computing expertise. Google has a very rich history with distributed computing. Hadoop is based on the original Google file system and MapReduce papers. More recently, announcing the really cool innovations with Spanner and the way that, kind of novel way that they handle transactions, distributed transactions across the globe. That's pretty exciting too. One other thing, while this talk and our focus so far has been on analytics, one of the things that's been a challenge for us at Pandora is real-time distributed computing. We built a sharding layer on top of Postgres way back in 2011 because there weren't a lot of choices for helping us scale out for a real-time data store. So right now we're focused on analytics, but we're doing some investigations with both multi-regional Spanner and Bigtable as potential data stores for our real-time services. So that was a really good fit, and Google's focus on AI and machine learning was a really good match for us. The investment in TensorFlow, the ability to run specialized computing hardware for graphics, the TPUs is pretty exciting. In particular, we had a lot of success with BigQuery as well, and we'll go into some more details as we get into the meat of this. So we kicked off an evaluation just to give you kind of a sense of the timeline. We're a good-sized organization, and this was a big change for us. So it took some time to get buy-in from the business, to get everybody aligned, and make sure we're moving forward in the right direction. So we kicked off some preliminary research into the various cloud providers at the end of 2017. In Q1 2018, we did a proof of concept, spent about 3 months building that up. And by the end of that, from a technical point of view, we knew what we wanted to do. We knew what we wanted to go to GCP. We spent a couple months working with a lot of the stakeholders around the business, our partners in finance, building out a financial model. Something that was tricky for us is that we had this big investment on-prem. We had a colo lease that went out several years. We had a lot of hardware we'd already invested in. And so how do we make the switch to on-prem? It's not, or to GCP and the cloud, and it's not something that happens overnight. So it took some creative work there to make the numbers work out. But we got to a point where we feel like when we finish this migration, we're going to be in a good spot and very comparable cost-wise to where we are today on-prem. So at the end of the end of last year, we started our migration planning, trying to figure out the priority of how we migrate and move forward. In Q1, we migrated some of our initial data sets, and at the end of this month, we're looking to get our first set of early adopters onto the GCP platform, which is pretty exciting. Still a long way to go, but making great progress. So with our POC, what we did was took one of our largest data sets. So this data set is, it's called MADS, Master Advertising Delivery Data Set. It's really all of the ad impressions that, for all the ads served on Pandora. It's a very large data set, one of our largest, about 15 billion records in this data set every month. We keep a couple years, actually 2 or 3 years, of this data around for long-running campaigns and to do history. So move this process up onto GCP, leveraging Dataproc. It's really a Spark job that combines a lot of different data sources into one data set, normalizes that data, and puts a lot of, abstracts away a lot of the business logic that downstream consumers of this data, so they don't really need to know about that. So this all went really well. We found increased query performance with BigQuery. I'll get you some numbers in a minute. The batch workload was also optimized, about 35% fewer resources to do the same amount of work. And then this consolidation I mentioned, we were able to move all of these sources into a singular table. So this is my favorite slide. This was actually, what we did was we took the gnarliest queries that we ran on-prem on this data set, and we ran them against BigQuery, ran them against our Presto instance on-prem, against our Hive on-prem. And I think not only the quick results here, but the consistency across all under 30 seconds here, very reliable. So this was really, really exciting for us. So as we talk about the migration, this is a long process. We have a lot of jobs running on the cluster, a lot of users on the cluster. We think this is about an 18-month effort, and we're part of the way in. Originally we did a pilot. We moved a couple data sets up, different types, got some experience, did a lot of the infrastructure work. Cloud is new for us. I'll talk about that in a minute, but it's a different animal, and there was a lot of learning there. Now we're deep into the core data sets, migrating the data sets that are most heavily used by the company up there. We'll do that, and then there's going to be some long tail and also an opportunity. We've built some tools that tell us really what's being used on-prem, how often it's being used, and so to do that, we've been able to prioritize the workloads that we're moving over, and I think we'll do some spring cleaning as well. So areas of focus, I mentioned we spent a lot of time on the infrastructure. We wanted to get right, and it was a new muscle for us. So we leverage Terraform very heavily. We want everything to be really repeatable between our operations team and our tech ops team. They built essentially a project creation tool. So someone that wants to go and use the GCP platform at Pandora now goes to a portal, gives us some information, gives us some contact, and relevant information about what this project is going to be used for. And that kicks off some Terraform that goes and creates the project, gives them the right set of permissions, and does things in a standard and reproducible way. So that was really cool. VPCs were another thing. Took us a while to get right. We worked a lot with the Google PSO group and some of the product teams. Learned a lot there, but also automated that as well, so the VPCs get attached to these projects as they get created. Also, an important thing for us was budgeting. So being able to map these projects to different budgets and understand what that use case was going to be, because even now, just our short time on GCP, I think we're at, nearing 100 projects or so. And then, of course, the users are going to be an important track. It's a switch. We use Hive. We use Presto on-prem. BigQuery is still SQL, but there's some nuance there. There's some UDFs that we'll be transforming, and it's going to be a learning process. We think we're going to do this in a few different tracks. We'll have some training for different types of users. We've got the administrators that have been kind of trained up already. Different tracks for a developer, scientist, and analyst to learn about the platform. So this is really cool. Very early on, we figured out that we actually have a lot of cruft on our system. We've been around for a long time. We want to make sure we're spending our time moving the things that are most important. So shout out to one of our engineers who's in the audience here, Kate Shimada. She went and created what we call the lineage tool. So scraped all the logs from our on-prem cluster. Think timeline server logs for TES, job history for MapReduce, some logs for Presto and from Airflow. Kind of pulled all that data together, figured out the relationships, parsed the actual queries that are being run, and figured out things like what are the top queried tables, dependencies between data sets, what are like two commonly paired tables that people join on together when they're running queries, and then what are the least queried tables? What are things that just aren't really being used, and those are prime candidates to be axed and do a little cleanup. So as we get into migration, we took the data from the lineage tool, broke it up into sort of functional areas of work, assigned leaders to the different areas of work, and then we're actually also using the same tool to sort of check off data sets and jobs as they get migrated and move over to GCP. All right, I'm going to hand it over to Blake, and he's going to go into a little more deep into the technical details.
Thanks, Brett. So I just first want to call out the team and the timeline. So first off, Google PSO engaged with Pandora in around November of last year, along with a wonderful partner. Some of those members are in the audience today, so Nudesic. So this was really a combined effort between Pandora's excellent engineering organization, Nudesic, and Google PSO. And we're going to tell you a little bit about what the architecture looks like in GCP. So one of the first things we did is kind of target, Pandora has a large monolithic cluster on premises, and Brett did a really good job of showing like some of the inefficiencies and some of the bursty workloads and some of the drivers that push them to the cloud. And so they were also facing kind of some operational burden. So they really chose GCP Dataproc, which is GCP's completely managed Hadoop platform. And we really run Dataproc in two different ways. So on the left-hand side, we see that we spin up Dataproc clusters in around 90 seconds or so that are scoped to particular jobs. So this is ideal for batch or ETL processes that get run on a daily basis, if not more frequently. And so what we see here is that we're using Apache Airflow in the form of GCP Composer, a managed version of Apache Airflow, to basically identify how much data needs to be processed, spin up a right-sized Dataproc cluster, do the ETL or batch process, and then persist the result back to Google Cloud Storage or push it into BigQuery. On the right-hand side, there are some use cases that Pandora undertakes, like the use of Hive or Presto for interactive query to support 150 or so users throughout the day. And these are served best by long-living or moderately living Dataproc clusters. These clusters can actually be spun up in an optimized fashion per workload. For example, Hive may need a more balance between compute and memory, while Presto would have more memory-intensive machines. It also allows the Pandora team to spin up new clusters, test out new versions of software via new Dataproc images to see if they can upgrade to a new version of Hive or Spark, et cetera. On the edges of some of these things are some operational tools that are used on a daily basis. So these include things like Google Stackdriver, which has direct integration with GCP Dataproc to pull out a lot of yarn metrics, amongst other things, as well as like Google Cloud Logging for IAM and other metrics. And then lastly, kind of on the edge nodes, clients can use edge nodes either in the cloud to spin up Jupyter or Zeppelin notebooks, or they can also access across their interconnect from their on-premises systems. So now I'm going to kind of walk through, kind of all the pillars of a successful data platform on GCP, and kind of what are some of the things that Pandora, some key decisions they kind of had to make, and kind of what steps that they had to take. So the first thing we're going to talk about is data ingestion, right? So Pandora has over 7 petabytes of data on their Hadoop cluster on premises today, and they needed to devise a plan to get that into GCP. So the first thing is connectivity. We typically, when we work with customers, we look to see if which pattern is right for them. either moving it across the wire or using some type of transfer appliance. In this case, Pandora, when we started working with them, had a 10 gig link that was to GCP. And over the course of the project, that was increased to 40 gigabit. We also learned throughout the project that, like Brett mentioned earlier, with his comments on VPC, that network design is key. So working with infrastructure folks in the beginning to make sure that you have that foundation is very, very important. Next we had to, now that we had connectivity established, we had to go, how are we going to get data into GCP? How are we going to get into Google Cloud Storage to realize that separation of compute and storage? So there's really 3 different patterns for doing this. And for those that are interested, these slides will be posted in PDF form, and this is actually a link. So there's push versus pull versus kind of having a proxy cluster. So I'm just going to focus on push versus pull. The push model is you have a Hadoop cluster on premises that you install a GCS connector jar into, and you point it at Google Cloud Storage and move the data over time. The other scenario is you can spin up a Google Cloud Dataproc cluster in GCP, point it at your on-premises cluster, and pull the data. There are pluses and minuses to each approach, and you can read more on the link. So Pandora decided to do with the push model, use their existing cluster to push data into GCP, one of the more easier options. But to do this, they kind of ran into an issue. There is a mismatch between checksums between Hadoop historically and Google Cloud Storage. And not just Google Cloud Storage, but object stores in the cloud in general. At a high level, this has to do with a mismatch between MD5 and CRC checksums. So one of the senior staff engineers within the Google Cloud Dataproc team developed a patch, HDFS 13056, which is a patch to HDFS. So the Google PSO team, Nudesic and Pandora, collaborated on this patch and applied this to Pandora's on-premises cluster through a dev, through a dev test, and finally a rollout to their 2,700 node production cluster. So this really allowed them to move the data from on-premises to the cloud, have assurances that the integrity of the data was preserved so that they can start deleting data sets from on-premises, and that has just started. Next is, when dealing with data copy, when moving from on-premises to the cloud, you have to be cognizant of data access. And so what I primarily mean about that is the cost of ingress and egress from Google Cloud and cloud in general. The first is ingress. So as we move the 7 petabytes of data from on-premises to the cloud, we don't have to worry about that charge. It is completely free. But we do have to be kind of cognizant of egress charges, and they come in 2 main forms. One is across zones in a particular region, and when moving between regions. This is especially important when dealing with disaster recovery, and we're going to talk a little bit about that later. But lastly, due to Pandora's kind of major investment in BigQuery, it really kind of softens a lot of that, right? So any query egress from BigQuery is completely free. So when you're serving analytical applications or BI tools, either in the cloud or back on premises, any egress from that engine is free. And the last thing I just want to share about this slide is that there's a great, excellent blog post that goes into the details between the HDFS patch that is required to ensure data integrity between on-premises Hadoop clusters in the cloud, and you can read more by clicking the blog post link. Next thing I want to do is talk a little bit about cloud storage. So we're moving data into cloud storage. On-premises in an on-premises Hadoop cluster with HDFS, there's not the nuanced durability, availability, resiliency in the storage. There is a concept of storage tiering, but there isn't quite the same analog into the cloud. So the first things that we had to deal with were kind of like storage classes. So Pandora worked with the PSO team to kind of understand what was right for them based on the different data sets that they had. So data sets come in a few major flavors. So data sets, gold master data sets that need to be highly available at a low latency. They need to be backed up and available to any type of DR system. There's data that's created due to intermediate processes of analytical jobs that can be rerun, and that data requires less resiliency, but high performance. And lastly, there's kind of just intermediate data that analysts use like throughout the data science process, and that may not need high resiliency, durability, or performance. And so what you see here is an engineer at Pandora, Iggy, really empowered his organization to understand all these storage classes via the decision tree, like on the right. And then next, moving on, is permissions. So a lot of times I go and I work with customers who are storing a lot of data in HDFS, and it's kind of amazing to see, although this isn't the case with Pandora, that the majority of jobs are accessed and a majority of files are owned by the Hadoop user, right? And so when moving to the cloud, having to understand, IAM, identity access management, service accounts, and principals is key, right? So we were able to kind of implement a project-based inherited security model with projects being scoped to applications and projects being available for dev test and production to kind of encapsulate the security of the actual application and its data. So this kind of goes without saying, but separating the compute and the storage really alleviate a lot of pain. Customers normally experience, as did Pandora, that when HDFS gets above 90% or so capacity, that it can bring the entire cluster to a grinding halt, right? So that is a problem that is completely alleviated by kind of moving to GCP and GCS, right? It also kind of increases transparency. So now that you have data up in GCS, you can really point any type of analytical engine on it, add it, and it's very, very easy. And then lastly, we talked about where we are in this process. It's very early days for Pandora, but one of the some of the discussions that are already ongoing are around object lifecycle, which usually requires custom tooling. Certain scenarios that are kind of covered under this include what happens when a data scientist or an analyst takes a gold master data set, runs a bunch of analysis on it, makes in a lot of analysis result, and it's just sitting in a GCS bucket. Now that you have access to unlimited storage, you may start seeing a little bit more cruffling around. So like, how do you manage that? How do you ensure that the permissions are correct? How do you ensure that data sets are known to be either intermediary or gold, so on and so forth. And so while manual processes may work at first, it's very common to build custom tooling to automate this. So here's the real meat of the data platform today is using Cloud Dataproc. So there's a few different ways of using Cloud Dataproc, and I've kind of tried to break them down here in 4 different ways. So we talked about ephemeral versus long-living Dataproc clusters, and so this Pandora basically settled on the 4 following methods for using Dataproc. So the first is long-running Dataproc clusters that run workloads like Presto or Hive, but are capable of auto-scaling. So when users are not using these clusters, they can scale down, save cost, et cetera. But whenever people come in the morning and start firing queries, that they can auto-scale, right? The next is long-running Spark jobs. Workload is like kind of streaming workloads. These kind of take advantage of auto-scaling, but may not scale back down due to some of the concerns around kind of intermediate data, right? And then the next 2 are around ephemeral clusters. So ephemeral clusters or job scope clusters can be brought up to do ETL. They can be created in 90 seconds. We can create a cluster that has 500 nodes that will run for a period of minutes, which would cost the same as one cluster running for a 1-node cluster running for 500 minutes, and just really see that immense speed up in the cycle time for the particular job. And while these don't necessarily auto-scale today, they can be dynamic at startup. So when you're using Apache Airflow or Composer to create these clusters, you can identify how much work is being done and pick the amount of nodes that should be used to perform this job, right? And then lastly is kind of ephemeral clusters. So jobs that may need to copy data from one place to another or perform some type of operation like analyze tables in Hive may be created ephemerally to spin up and spin back down in a short period of time. So there's a few things on the right that I kind of want to talk about, over the last 5 months that we were able to realize pretty easily by using a managed Hadoop service. So the first thing is, Pandora was able to upgrade to Hadoop 2.9. So you saw that they were running HTTP 2.6.4, which was Hadoop 2.7.2, and it had a lower version of Hive as well. So with very little effort, we were able to adopt a Dataproc image, with Hadoop 2.9 and Hive 2.3 and realize some performance gains. The next is, I want to talk a little bit about, customization of Dataproc. So Dataproc has base images, but they rarely have every single component that a, customer may want to utilize, and that was the case with Pandora, right? So Dataproc offers a series of top-level components that are baked into the image that are enabled or disabled based on flags. And so what this means is, since the bit's already built into the image, you can have a litany of components available within the 90-second cluster startup time, right? And so what this means is that you just write in an initialization action that has configuration and not necessarily bits that need to be installed, right? Because the sum of installing all those bits across a cluster, even a particularly large cluster, could be very costly, both in performance as well as cost. And then lastly, we talked a little bit about auto-scaling for Dataproc, but we do want to talk about workflow templates. So workflow templates are a recent innovation in Dataproc that really allows you to spin up a cluster, run a graph of jobs, and then let the cluster spin back down. So this really simplifies the job scoped ephemeral cluster model, where you once had to create a Dataproc job, submit jobs, and then understand when to shut down your cluster. This is now completely wrapped for you and easily called by scheduling systems like Airflow. Next, I want to talk a little about Cloud Composer. So Pandora is a very big investor in Apache Airflow. They primarily run Airflow 1.8 on premises and have over 90 instances today. These instances span the gamut of dev, test, and production. They have an extensive set of plugins that they use to do some really cool stuff. One of them is job dependencies. So not only do they have a series of plugins that will manage job dependencies across Airflow instances, but they also manage dependencies across legacy schedulers. And now recently, they've added functionality to also manage dependencies across the cloud as well, which is GCP Composer, which is managed Airflow. They also have a lot of cool operators that do things like sense whether data is in HDFS, sense whether or not a partition in Hive is available for down to basically enable jobs to understand if they can move down their dependency graph. Continuing on with the plugins, there's also kind of CI/CD built into the Airflow instances. Since Airflow is so pervasive at Pandora, it shouldn't come as a shock that it's not just engineers that use Airflow. It's a lot of analysts and scientists too. So how can you enable these people to quickly write a DAG and sync the updates to the system? So they kind of have a update DAG view plugin that kind of works across Airflow and Composer and GCP. When we started this project, upgrades to Composer in GCP were a little crufty, to be honest, right? So there was custom scripting that was required to upgrade minor, major versions of both Composer and its underlying Airflow. And we're really happy to report that as of I believe yesterday, new functionality was introduced in Composer that completely automates both tools upgrade automatically. And then lastly, I just kind of want to talk through this system on the right. So, the partner that I kind of called out in the beginning of this talk, really took the lead in developing a Composer DAG factory. And so what this is a framework that runs in Composer that encapsulates all the jobs that are being migrated to GCP from Pandora's on-premises. And so it really just wraps analytical business logic in a lot of pre-checks, sensor checks, task retries, logging, et cetera, validation, and then also queues, other processes for downstream processing as well. And so, this DAG factory is being used to wrap all of the jobs that are being moved to GCP from on-premises. If you want to learn a lot more about this, you can catch this great session that's taking place tomorrow morning. So Dan Barrett, a staff software engineer from Pandora who's in the audience here today, is going to be speaking with the Composer team about Pandora's move to GCP and Composer. That's tomorrow morning at the Metreon Theater 7. So next is BigQuery. So Pandora has recently been experimenting with BigQuery and is settling on a production architecture for its use. And so I'm going to kind of step through a couple concerns that customers typically have to understand when they adopt BigQuery. 1 second. So the first is workload management. So first off, before we kind of go into BigQuery, just a few concepts for those that are unfamiliar in the room. So BigQuery has a few constructs that are kind of important to understand before we go into this. The first is a slot, which is basically just a contract of a fixed amount of memory and CPU. You have a slot pool. So when you interact with BigQuery, you have a series of slots that you either use on demand or you have a fixed reservation of these. In this case, Pandora has 2,000 slots. They can make as many reservations underneath that slot pool as they would like for workload management, right? And this overall hierarchy is called the reservation hierarchy. And you see an example on the bottom right of the screen. So workload management is really here to enable SLAs. And this allows you to really maximize your investment in BigQuery. So what I mean by maximize is that what you see here is to kind of enable some SLAs, we're kind of breaking apart our slot reservation into batch and online, right? And we're giving particular projects and particular applications a fixed amount of computing and memory power, right? But if some of these if some of these slots are unused by these child projects, other projects can actually burst in and use them, right? So if, for example, the MADS project is done with its daily computation and is not using its slots, Zeppelin users, data scientists that are trying to use the systems will benefit. They can actually just go over and take those slots. The next is federated query. So BigQuery traditionally works on BigQuery storage. It's a highly optimized both file format and storage layer for BigQuery that really enables like true interactive query. But increasingly, BigQuery supports more and more federated query sources. So some of those include Google Cloud Storage, Cloud SQL, and a few others. There's wonderful announcements on that at Next 2019. So you can federate query across a variety of formats. So the formats that Pandora primarily uses, Avro, Parquet, ORC, the majority of those formats are supported for federated query. And BigQuery supports columnar data partition support. So if you have data in ORC or Parquet format, primarily ORC, BigQuery will understand partitions and actually do predicate pushdown and optimize the query, even if it's stored external to BigQuery. What does federated query kind of enable? Storage sharing. So it's very common for customers, and in Pandora's case, to store their most hot data, their last 90 days in BigQuery, and then push older or more historical data into GCS, and then do federated query across the two data sets when historical analysis is required. The next is high throughput API and external analysis engines. So we're innovating with Pandora. The Google PSO team is working to build a BigQuery storage handler that allows Hive and Presto to register external tables against BigQuery datasets. And this will allow for further federation of queries. So data that is historically preserved in GCS for multiple years can be actually merged with the hot data in BigQuery and queried with one analytical engine. And then lastly, exploration is kind of taking place with BQML. So for simple regressions, classifications, and increasingly other ML methods, like BQ is kind of making it effortless to run those against data sets in BigQ. So some kind of parting anecdotes about what we were able to accomplish over the last 5 months include kind of an approach for GCP disaster recovery. So like Brett was mentioning, there's an active cluster in California and a DR colo on the East Coast. And they're kind of following a similar model in GCP. So their primary region is US Central 1, with the DR region being US East 1. And so there's a couple of advantages of using the cloud for DR, right? So the first is that you don't have to, in an active standby mode, have resources be running in your disaster recovery, right? And if you needed to actually replicate your entire production environment in the cloud, That's possible by moving to a second region. But there was one really neat thing that Pandora is able to adopt within GCS that is going to make this quite effortless. So GCS has a bunch of storage tiering modes. So for those who are unfamiliar, there's multi-region GCS storage, regional GCS storage, and a special type of multi-region is called dual region. What this does is pin your data between two regions that are known. So that's especially useful in disaster recovery scenarios, amongst others. And so this NAM4 bucket type within GCS is used by Pandora to store its most important data and ensure that it's replicated from US Central 1 and US East 1 continuously and allow them to spin up and continue their business in the event of a disaster in US Central 1. And they can do that via CI/CD tools and infrastructure and code that they've developed throughout this project as well. And then lastly, kind of ending with a really early success story for some of the other tools in GCP. So there's the Pandora Music Genome project. So I encourage everyone to go to pandora.com/about/MGP and kind of learn a little bit about this. It's a very comprehensive analysis of music over time. And what this is kind of batch feature extraction and prediction using TensorFlow. And so traditionally at Pandora, this was done on a single server using other ML libraries, and it would take a matter of days. In the example here, over 6 days, right? So analyzing over 10,000 MP3s, extracting features for analysis was just done, very, very slowly. And they were able to quickly port that over to Dataflow after this data was loaded into GCS, and bring up 800 cores and complete this same effort in less than 4 hours. And that's just kind of the start of what they're doing with this. And so with this, I'm going to pass it over to Brett to talk about what Pandora is going to be doing for the rest of 2019 and what we kind of hope to see them talk about at next year.
Thanks, Blake. So just try to finish off real quick so we have time for a couple questions. We are part of the way down a pretty long journey here, but some things we're already realizing is the separation of storage and compute is one of the biggest wins that we're getting out of the move to a cloud, enabling this flexibility to scale out when you really need to, when you have a bottleneck, it has been really cool. As an example, we have this job that processes, it's essentially ETL on a lot of our listener data. It has probably the worst name possible. It's called the nightly job. It was the only job back in 2010 when we wrote it, but still does a lot of the core processing of our listener data. That used to run or currently runs on-prem in just a little over 5 hours. We moved that over to GCP. It's running in Dataproc now, and it runs in, I think, an hour and a half. So that was a big bottleneck. It's a big dependency for this long chain of jobs that we run every night. And so being able to scale that out, reduce the time, puts us in a good position to finish all of the other nightly processing and be ready for the next day. The operational overhead, let me talk about lift and improve a little bit. So being able to migrate, we didn't want to just lift and shift, take exactly what we're doing on-prem and move it to a cloud. So all these things I mentioned about being able to scale out have really helped us there. The ability to, a Hive upgrade used to be a really big endeavor for us. It took us about a year from start to finish to test out the major Hive version, to get all of our different teams that have tested the job and do that upgrade. And now with Dataproc and having ephemeral clusters and having jobs, being able to use whatever version they need to, we can do this in a much more staged fashion. Gives us a lot more control and flexibility. And the last thing I would say is lean on Google, lean on the PSO services. They've been a great partner for us. A big migration like this, things do not always go right. Features aren't always as advertised. That's just the fact. People use them in different ways. But Google has been a great partner. When we found an issue, we reported it. They get back to us very quickly, and we're iterating on it. So we really appreciate that. We know everything's not going to be perfect, but when you have a good partner, it makes a big difference. Also, early access to features. We got early access to catalog, or data catalog, which has been great. A lot of BigQuery features that we got access to early. So that was really helpful. So what's next for us? We're really focusing on optimization. So we're going to finish the migration beginning of next year. Along the way, we're doing a lot of optimization for cost, for speed, and then really digging in to see what we can leverage with all the tools to improve the personalization and listening experience for all of you on Pandora.